So we are in section 9.1. We're moving on to something called polar coordinates. So we know one way to plot points in the plane is take a flat surface and put down a y-axis, right, and an x-axis. And we grid off the plane. Here the x values to the right are going to be positives. 1, 2, 3, 4. And the ones to the left are going to be negatives. -1, -2, -3, -4. And along the y-axis, the ones above the x-axis are positives. 1, 2, 3, 4. And the ones below the x-axis along the y-axis are going to be negatives. -1, -2, -3, -4. This is sometimes called the rectangular coordinate plane. The rectangular coordinate plane. So for example, if I wanted to plot the points like 3, -2, say I find 3 on the x and 2 on the y, and boom, that would be, 3, -2, 3 on the x and -2 on the y. I'd be right here at this point, right? 3, -2. And if I wanted to plot, for example, let's call it q, -2, 5, I have to go -2 on the x and 5 on the y. And I get that point right there. So this is our famous rectangular coordinate plane, or sometimes called the Cartesian, right? It's called the Cartesian after Rene Descartes. Cartesian coordinate plane or rectangular coordinate plane. So we want to learn a new method of plotting points in a plane. We're going to develop a new coordinate system. We're going to call it polar coordinates. Polar coordinates. So imagine I take a vertical here, line, a horizontal line. Now this is not really going to be an x-axis and a y-axis. These are just for kind of guiding our angles. We're going to have angles. So imagine here the center is right here. That's called the origin or the pole. Then we're going to have a circle of radius 1 around that. And a circle of radius 2 around that. Circle of radius 3 around that. Circle of radius 4 around that. Circle of radius 5 around that, and so on. So we have these concentric circles. So what I want to do, I want to plot the points in the polar plane. This is called the polar plane. So to do polar coordinates, we're going to have first radii and then angles. So number 1, let's say I wanted to plot the point 4 pi over 6. 4, pi over 6. So polar coordinates are of the form r, theta. R equals the radius, or the distance from the center. And theta is the angle in radians. Not degrees, but radians measure. So when I do 4, pi over 6, that means I have to end up going to pi over 6. Pi over 6 is 30 degrees, so that's like right about here. Let me get that in red. There's an angle of pi over 6. And I'm going to put down a radius of 4, so a distance of 4. So here's my point right there, my P. Number 2. Say I have an angle of Q of 3, and then 3 pi over 2. That means I'm going to have to go 3 pi over 2. Where's 3 pi over 2? 3 pi over 2 going all the way around to 270 degrees right here. So I'm right here. 3 pi over 2, 270 degrees. I'm going to go out a radius of 3. 1, 2, 3. So I'm going to be right here on a circle of radius 3. That's my point Q. As far as number 3, doing a point R, I have 2 negative 4 pi over 3. So that means I'm going to go negative 4 pi over 3. Remember where positive 4 pi over 3 is. Positive 4 pi over 3, I would go all the way to pi and then go additional pi over 3. So that would be positive 4 pi over 3. But I don't want to do that, right? I want to go negative 4 pi over 3, so I'm going to go all the way around this way here. Oh, I did something crazy. So I'd be like right about here, right? So that's right about here, 4 pi over 3. And we're going out a radius of 2, or a distance of 2 here, right? 1, 2, so I'm right here. So that is my point. What point is that? That is my point. Q, R, right, that's my point R. Yeah. So R is that green point right there. Okay, let's do S. Let's plot a point called S. Negative 2, comma, pi over 4. So first I'm going to start off with an angle of pi over 4. I'm going to make this one yellow. So pi over 4 is just your like typical 45 degree angle, right? Pi over 4. Oh, so this was a minus. I'm sorry, this is a minus 4 pi over 3. So back here. Okay, so back to pi over 4. Pi over 4 is that yellow 45 degree angle, but we're going negative 2. So what happens when we have a negative? When we have a negative radius. So negative radius, what we're going to do, we're going to flip over top of the origin. So we're actually going to go back this way and go 2 in this direction. So actually our S is going to be back here in the third quadrant. So again, I'll go over that. So first I go pi over 4. So pi over 4, I'm starting with my angle right here of pi over 4. But since I have a negative radius, I got to go to the opposite side of the circle, which is down in quadrant 3, and I'm going to go 1, 2. So I'm going to end up there. So there we go. That's S. All right. So be careful about those negative radii. You got to flip them to the opposite side. Let's do another negative radius. Negative 1, comma 3 pi over 4. So I'm going to start off, let's see, with a purple color this time. So 3 pi over 4, that is 135 degrees. So that's like right there, right? 3 pi over 4. And since I got a negative, all right, so this guy's a negative, I actually got to flip to the other side of the circle. I'm going to go 1 in that direction. It's going to land me right there in quadrant 4. That's going to be my T. All right, so that's plotting some polar points. Okay, let's do one more. This one is a number 6. So here we have U, negative 4, and negative pi over 2. So first you got to go negative pi over 2. So what color are we going to use for that? We're going to use like an orange, right? So negative pi over 2, that would be going in the clockwise direction. So that's negative 90 degrees that way. So I start off here, but then, so I got negative pi over 2 is right here. But then because I have a negative radius, I got to flip over to the opposite side of the circle. I have to go out 4. 1, 2, 3, 4. So right here at this orange point, U. There's plotting some polar points. That was negative pi over 2. All right, so what are we doing next? We're going to learn how to write additional ways to write polar points. So additional forms of polar points. So it turns out that polar points can be written in more than one way. So let's say we have a point in the form r comma theta, so a polar point. Then number one, I can rewrite this point. I can keep the r the same, and I can change the angle. I can add or subtract 2 pi times any integer, where k is any integer. Yep. So what does that mean exactly? Well, that means, okay, so let's say I have a polar point. So I'm going to have a certain radius, a radius of r, and a certain angle theta. So all I have to do, I can rewrite this by adding 2 pi, or any multiple of 2 pi. I can add 4 pi, or 6 pi, or 8 pi. So I can add any multiple of 2 pi to my theta value here. That's just telling me I'm doing additional rotations. It's going to take me back to the same position, so it's essentially the same point. But that's one thing you can do. You can either add or subtract multiples of 2 pi. Number two, if I decide to switch my r value, what happens? So let's say I got a point here. There's the r, there's the theta. Let's say I switch the sign. If I switch the sign, it's going to take me back in this direction, right? Take me back here. So that would be if I had a negative r. It's going to take me back to the opposite side. So what do I need to do to get back to my starting position? I need to either add pi, or I can subtract pi to the angle. So I can either do theta plus or minus pi. And then to that, if you wanted to, you could add any multiple of 2 pi k if you wanted to. But generally, I'm just going to add pi and subtract pi. I'm not going to bother adding additional multiples of 2 pi, because additional multiples of 2 pi would be a multiple of 2 pi, another multiple of 2 pi, another multiple of 2 pi, just kicks you back to that same position. So generally, I'm just going to add pi or subtract pi when I flip the r value to a negative. So let's see if we can work some problems where we find additional ways to write our polar coordinates. Exercises. Find 2 other polar coordinates. For the point, one with r positive and one with r negative. Okay, so what we're going to do, we're going to get a polar point, and we're going to write this in another way. So first we want to keep the r positive. And if we keep the r positive, if we don't change the r value, that means we should probably add 2 pi to the angle. So 2 pi over 3 plus 2 pi. So that's going to be 4 comma. So we have 2 pi over 3. I want a common denominator here. Common denominator is going to be 6. We're going to write 2 pi as 6 pi over 3. So we're going to end up with another way to write the point is 4 comma 8 pi over 3. Now that's when the r is positive. Now let's do flipping the r to a negative. So we're going to make that a negative 4. Remember, when you make that a negative 4, you need to take 2 pi over 3 and either add or subtract pi. So I'm just going to add pi. So we got negative 4 comma 2 pi over 3. Common denominator here is 3, so I'm going to write pi as 3 pi over 3. So an alternate way to write this point is negative 4 comma 2 pi plus 3 pi, 5 pi over 3. So here are two ways, the red one that's boxed in and the blue one that's boxed in, to rewrite our point P. Two additional ways to write it. One with a positive R value of 4 and one with a negative R value of negative 4. All right, so here's another. Let's say I got Q is 5 comma negative pi. So we can rewrite Q, keeping the R value 5, and taking negative pi and adding 2 pi to it. That'll give us 5 comma negative pi plus 2 pi is simply pi. So 5 comma pi is the same point as 5 comma negative pi. Let's do Q, where we make the 5 negative. So we're going to take a negative R value, negative 5. That means we're going to have to take negative pi and we're going to have to add pi to it. So negative 5 comma negative pi plus pi is 0. Negative 5 comma 0. In polar form, remember this is polar form, this is not rectangular form. Negative 5 comma 0 is the same thing as positive 5 comma negative pi. All right, let's do another. Let's say we have R is negative 3 comma 7 pi over 6. We're going to rewrite R with a positive R value. So if we decide to make this negative 3 a positive, then it has to be positive 3. And we have to take 7 pi over 6 and add pi to that. So when we flip the sign on the R value, when we flip the sign on the little r value, you have to add pi to the angle, or some pi plus some multiple of 2 pi. I'm just going to add pi though. That's 3 comma, so 7 pi over 6 plus pi is 6 pi over 6. So we got 3 comma 13 pi over 6, right? 7 pi plus 6 pi is 13 pi over 6. That's when R is positive, little r is positive. If we want to maintain little r is negative here, we're just going to take 7 pi over 6. We're not changing the sign, we're going to add 2 pi to the angle. It's going to be negative 3 comma 7 pi over 6 plus 12 pi over 6, right? 2 pi is 12 pi over 6. So we get negative 3 comma 7 pi plus 12 pi, that's 19 pi over 6. So negative 3, 19 pi over 6. Another way to write that point. Okay, so something we want to do going forward is, how do we convert from our rectangular coordinate system, or from our polar coordinate system to a rectangular coordinate system? Convert from polar to rectangular coordinates. So let's imagine here you have a point of the form. So the polar form is r comma theta. That means I have a certain angle here of theta, and I'm on a circle of radius r, right? Well, this also has a rectangular coordinate, has a pair of rectangular coordinates x and y, right? So here's the x, and here's the y, right? So if I focus on this little blue triangle right here, so we got our angle is theta. We have our radius here is r. It's going to be the hypotenuse, right? That's that. We have the x is this side, and the y is this side. It turns out that if I take the cosine of theta, that's going to be x over r, right? The adjacent over the hypotenuse. So if I get x by itself, I get that r times the cosine of theta equals x. So I can convert from polar here to a rectangular x value by taking r times the cosine of theta. Now similarly, I can find the sine of theta by taking the opposite y over the hypotenuse r. I'll bring the r up here. It'll give me r sine of theta equals 1. So I can convert from polar to a rectangular y value by taking r sine of theta. So, in conclusion, we can say this. If r theta is a polar point, then xy is the associated rectangular point when x equals r cosine of theta. I can spell that cosine of theta. And y equals r sine of theta. So these are the two formulas you need to remember for converting from polar to rectangular. So x equals r cosine of theta, y equals r sine of theta. So let's say I wanted to do that. Let's say I wanted to convert from polar coordinates, r thetas, to rectangular coordinates, x, y's. Let's see if we can do that. So exercises. Polar coordinates of a point are given. Determine the rectangular coordinates of the point. So number one, here we have a point, 4, 3 pi over 2. This is polar. So here our r is 4 and our theta is 3 pi over 2. So if I wanted to find x, rectangular coordinates, I would say x equals r cosine of theta. In other words, x is 4 times the cosine of 3 pi over 2. So 4 times, what is the cosine of 3 pi over 2? Well, remember where 3 pi over 2 is. It's a 270 degree angle right here, and it has a terminal point of 0, negative 1. And the cosine here is the x value right at 0. So the cosine of 3 pi over 2 is 0. We've got 4 times 0 is 0, so our x value is 0. Our y value is going to be r sine of theta. In other words, y equals 4 sine of 3 pi over 2. Now the sine of 3 pi over 2, remember, is the y coordinate here, which is negative 1. Negative 1 for our terminal points. And we're going to have 4 times negative 1 is negative 4. So the rectangular point is going to be 0, negative 4. It's a rectangular point. Let's see if that actually makes sense. So let's plot first our polar point. So you go, first of all, 3 pi over 2. So 3 pi over 2 here is a 270 degree angle, right? 270 degree angle, 3 pi over 2. And I'm on a circle of radius 4. 1, 2, 3, 4. So I'm somewhere like down here. There's P, right? 3 pi over 2 is the angle. The radius is, or the distance from the center is 4. Is that the same as 0, negative 4? Yeah, right? You got 0 on the x and 1, 2, 3, 4 negative on the y. So yeah, it makes sense. All right, next we got the point Q, negative 2, pi. I want rectangular coordinates. going to say x equals r cos theta, y equals r sine theta. Of course, r is -2 and theta is pi. So I'm going to have x equals -2 times the cosine of pi. We know the cosine of pi is -1, so we got -2 times -1 is 1. Sorry, 2. -2 times -1 is 2. And for y, we got -2 times the sine of pi. Of course, we know the sine of pi is 0, so we got -2 times 0, so we got -2 times 0 is 0. So our polar point was -2 comma pi. Our rectangular point, this is called q, right? Q is going to be 2 comma 0. Let's do another one. Number 3. Here I got r -3 comma 2 pi over 3. Let's find, so this is r, this is theta. Let's find the rectangular coordinates, the xy coordinates. We have x equals r cos, how do you spell cos? Cos theta. We have y equals r sine theta. It's going to be -3 times the cosine of 2 pi over 3. And we're going to have, for y, we're going to have -3 sine of 2 pi over 3. Let's work with x. We got -3 times, what is the cosine of 2 pi over 3? Well, 2 pi over 3, that angle is right about here. So in the unit circle, that's our angle 2 pi over 3. You have a terminal point of -1/2 comma √3 over 2. So the cosine is the x coordinate of -1/2. So you got -3 times -1/2 is +3/2. As far as the y value, we have -3 sine 2 pi over 3. That's going to be -3. The sine of 2 pi over 3 is the y coordinate here, √3 over 2. So that would be y equals -3 √3 over 2. So our point here, r, is 3/2 -3